Often, a perfect lake in the heart of summer gets a thick, green, paint-like slick. This isn't just pond scum. It's a sign of a complex and growing problem. This phenomenon is a harmful algal bloom, or HAB. It happens when a specific type of organism grows explosively, accumulating on the surface of a lake. These blooms form dense, intensely colored scum and can release dangerous toxins that ripple through entire water bodies, threatening drinking water, wildlife, our pets, and our own health. But here's the first critical detail. Harmful algal blooms are not caused by all algae. In fact, the primary culprit isn't algae at all. It's a group of ancient bacteria called Cyanobacteria. You might know them by their other name, blue-green algae. These microscopic organisms have unique traits that, under the right conditions, allow them to completely take over a body of water. So, what are these conditions? What does it take to trigger a full-blown HAB? It's not one single thing, but a perfect storm of three key factors occurring together. First, you need high nutrients. Cyanobacteria are voracious eaters, and their favorite foods are phosphorus and nitrogen. In the past, these nutrients would wash into lakes from sources like agricultural runoff, leaky septic systems, fertilizers from lawns, and untreated stormwater. While those sources are still a major problem, in many lakes today, the biggest threat comes from within. Decades of pollution have settled at the bottom, creating a massive reserve of nutrients in the sediment. When this is released back into the water, it's called internal nutrient loading, the ghost of pollution past continuously feeding new blooms from below. This leads directly to the second trigger, low oxygen in deep water. In a healthy lake, the deep water is well oxygenated, but when excess organic matter, like dead algae from previous blooms, sinks and decomposes, it uses up that oxygen. This state, called hypoxia, fundamentally changes the water chemistry. It causes the lakebed sediments to release even more of that stored phosphorus back into the water, creating a self-perpetuating feedback loop. Low oxygen releases nutrients, which fuels more blooms, which die, sink, and create even lower oxygen. The final trigger is calm, stable, stratified water. This is where cyanobacteria reveal their superpower, buoyancy control. They are equipped with tiny gas-filled sacs called vesicles. Think of them as microscopic ballast tanks. By adjusting the gas in these vesicles, they can control whether they float or sink. This gives them a massive competitive advantage. They can sink down to the dark, nutrient-rich bottom of the lake to load up on phosphorus released from the sediment, and then float back up to the sunlit surface to photosynthesize, multiply, and form a bloom. They commute to their food source, something other phytoplankton, the true algae, can't do. When these three conditions intensify, high nutrients, warm water, calm conditions, and deep water hypoxia, cyanobacteria leverage their unique advantages and begin to multiply exponentially. The entire community of microscopic life in the lake shifts, and this marks the beginning of a harmful algal bloom. Once triggered, the process accelerates. The cyanobacteria, having loaded up on nutrients from the bottom, use their gas vesicles to rise to the surface. There, with unlimited sunlight, they multiply at an astonishing rate. The bloom becomes visible to the naked eye, forming a thick scum that can look like spilled paint, often in shades of blue-green, vibrant green, or even a reddish-brown. But the bloom doesn't stay put. Wind and currents act like shepherds, pushing and concentrating these surface scums along shorelines. This is where the danger becomes most acute. The concentration of the bloom means a concentration of its toxins, creating hotspots of exposure for people, pets, and wildlife that use the water's edge. The danger isn't just in the water either. Recent medical research is finding that these toxins can become airborne, aerosolized by wind and waves. Incredibly, toxins have been detected in the nasal passages of people living a couple of miles away from a lake experiencing a severe bloom. And this brings us to the most dangerous aspect of HABs, the toxins themselves. Many species of cyanobacteria produce potent poisons called cyanotoxins. There are several major classes. Microcystins are hepatotoxins. They attack the liver. Anatoxins are neurotoxins, targeting the nervous system. Others, like cylindrospermocin and saxitoxins, affect the kidneys or can cause paralysis. The specific mix of toxins depends on the species of cyanobacteria present in the bloom. Exposure can cause a range of health effects, from skin irritation and rashes after swimming to severe illness in pets and livestock that drink the contaminated water. It poses a significant risk to drinking water safety, as municipal water intakes can draw in toxins, overwhelming standard treatment systems if not carefully monitored. For wildlife, the results can be catastrophic, leading to stress, sickness, and mass die-offs of fish and birds. For humans, while skin contact is a concern, the greatest danger comes from ingesting water containing these potent toxins. Surface scums are the most hazardous zones, as they can contain toxin concentrations hundreds or even thousands times higher than the surrounding water. This might sound like a localized problem, one lake, one bad summer, but it's not. Harmful algal blooms are on the rise, becoming more frequent and more intense across the whole of the United States and all over the world. And this global increase is being driven by 5 interlocking global trends. Trend number 1 is rising nutrient loads. Despite better management in some areas, the continued pressure of urbanization, agriculture, and industrial development means more and more nutrients are making their way into our watersheds. And even in lakes where we've successfully cut off external sources, that internal loading, the nutrient bank in the sediment, continues to perpetually feed blooms. Trend 2 is our warming climate. Warmer waters do 2 things. They extend the growing season for cyanobacteria, allowing blooms to start earlier in the spring and last longer into the fall. And, critically, higher temperatures intensify thermal stratification. This is when a lake separates into a warm surface layer and a cold deep layer that don't mix. This creates that calm, stable surface water where cyanobacteria thrive. Trend 3 is more extreme weather. Climate change is bringing a 1-2 punch. Intense, heavy storms act like a fire hose, washing huge pulses of nutrients from the land into lakes all at once. Then, prolonged heat waves follow, rapidly warming the water and creating those perfect stagnant bloom conditions. Drought, on the other hand, reduces the amount of fresh water flowing through a lake, lowering flushing rates and allowing contaminants and bloom formers to accumulate. Trend 4 is changes in our aquatic food webs, often driven by invasive species. For example, invasive zebra and quagga mussels are incredibly efficient filter feeders. But they are also picky eaters. They consume vast amounts of beneficial algae, but will spit out toxic cyanobacteria. In doing so, they remove the competition and increase water clarity, allowing sunlight to penetrate deeper, which gives the cyanobacteria an even greater advantage. Finally, trend number 5 is a direct consequence of our warming climate. Longer stratified periods. Because summers are getting longer and warmer, that stable layering of lake water persists for more of the year. This extends the window for surface blooms to form and for oxygen to be depleted in the deep water, reinforcing that vicious cycle of internal nutrient release. So let's put it all together. Harmful algal blooms are not a simple problem of too much algae. They are complex events caused by a specific organism, cyanobacteria, which thrives when a precise set of conditions are met. These conditions, abundant nutrients, warm and calm water, growing hypoxic zones below the surface, and internal nutrient loading, create the perfect environment for them to bloom and form toxic surface scums. And the global trends of our time, climate change, nutrient pollution, and altered ecosystems, are stacking the deck in their favor. This isn't just an ecological curiosity. It's a growing global challenge to the health of our freshwater systems and a direct consequence of how we manage our land, our water, and our climate.
To catch a bloom before it starts, scientists have to take the breath of a lake. Join us in Lesson 6, Reading a Lake's Health, where we learn how to read dissolved oxygen (DO) profiles to find the hidden dead zones where these problems begin. To go to the next lesson, use the link below, and don't forget to subscribe, like, and share.